Now let's talk about the arc length of a curve defined by a polar function. So the arc length equation that we had previously is L equals the integral from a to b of the square root of, and I'm just going to write x prime t squared plus y prime t squared, square rooted dt. So what we know in polar is r equals f theta. And we also know x equals r cosine theta. And we know y equals r sine theta. So using all of this information, we're just going to kind of sub things in here and get to the formula that we can use very easily. That's very straightforward. So what we're going to do first is, I know my r equals f theta. So now I'm just going to take that and sub that into both of these here for r. So then my x is going to equal f theta cosine theta, and then y is going to equal f theta sine theta. And then when I take my x prime here, my x prime of t, we have a product rule here. So it'll be a derivative of the first times the second plus the derivative of the second, so I'll have to change my sign here, times the first. So I changed it because the derivative of cosine is negative sine, so that's why I got a minus there now. So I'm going to do the same thing for y prime of t. And that's just a product rule also. So f prime of theta times sine of theta plus f of theta sine of theta. Excuse me, cos of theta. Get rid of the second one. So there's my two derivatives of my xt and yt. And then again, now think of it this way. Now I'm going to have to take these here and just sub them into my formula. I'm going to do that for both of these here. I'm going to sub that in for my y prime of t. Now again, notice that's not the squared, it's just the y prime of t. So I am going to have to take those and square them also. So I think what I'll do here is I'll square them both first. Oops. So this is going to be x prime of t squared that I'm going to do here. So remember now, this is a FOIL we have here. So this is really f prime of theta cosine of theta minus f of theta sine of theta times itself. So now I'm just going to do a FOIL here. So I'm going to do the first times the first times the last, the second times the first, and the second times the last. So there's the x prime of t. I just kind of showed all the work for that, the FOIL. And then I'm going to end up with two of them. And that's because of this one here and because of this one here. So there's my answer for that one now. Y prime of t. I'm going to skip all of those steps and just write out the answer for that part. So there's the other one. Now keep in mind I'm adding these together because if you notice here, there's a plus between both of those. So I'm adding those together there. So here's my x prime t squared and my y prime t squared. And those I'm just going to add together. And if you look at this, these two middle pieces here are are the same, and one's positive, one's negative. So those are actually going to cancel right out. So as bad as that looks, it really simplifies nicely. And those I can add together. Oops, I forgot something here. This is actually a squared there. Okay, so these I can add together. And then these I can add together. Okay. And if I add those together and factor out an f prime theta squared for these two, and then I take these two and factor out a f theta squared, notice what we end up with here. And we know that these actually equal 1. So we actually get, by adding those together, we get f prime of theta squared plus f of theta squared. Actually simplifies very nicely. Now, when I put that in my handy dandy formula here, this is going to be the integral from alpha to beta, and this is going to be the square root of, and simply all of this in here is just going to be f prime of theta squared plus f theta squared, square rooted d theta. So that's our other formula now that we have, that we can use in polar there. So we can simplify this a little bit more as well. And I don't think that it really simplifies it, but it's another way to look at it. This is still alpha beta. If I look at f prime of theta, that's just dr d theta squared plus, and f theta is referred to as r, so it could be an r squared there, and d theta. So just a few different ways we can look at just the length now using polar coordinates.